Alright, I'm hoping that you've seen the last video and you've either done the exercises and realised it's so doable, or you've at least watched the video and thought, yep, I can do that. So same with this. Now we're going to differentiate logs, and although it's a bit different, it is super okay to do as well. So if we have a look here, we've got g of x equals log of e f of x. We get differentiation on the top of f of x, so no log anymore, and on the bottom we list f of x. Okay, and in this way you'll see the logs disappear. I'm going to go straight for it because you're going to be fine. Alright, so from y we're going to get the derivative, so we're going to go dy dx straight away. So what does this say? Differentiate this part. Okay, so we're not going to worry about the log e. Differentiate that, put it on the top of the fraction, and then we're going to write the original without the log again, as up here, 4x. So this is like differentiating 4x divided by 4x, okay, or divided by, yeah, that'll do, because that is f of x. So your final answer is 1 over x. Awesome, easy. All right, let's have a look at the next one. I'm just going to separate this. Most of you won't need to do it, but I like to do everything when we do the examples. Now we're going to do dy dx. Okay, so we're still going to leave the 3, all right, because that's out the front. We want to worry about this. We've just done this, so we know that it's 4 over 4x, or we could have gone straight to the fact that that's 1 over x because we just worked it out. So your answer is going to be 3 divided by x. All right, so next one, dy dx equals, on the top we want the differentiation of what's inside the brackets, so this is going to become 6x squared plus 1. On the bottom is just the original. Now you can see there's nothing, no common factors, so we can't in fact go any further than that. That's the end of the question. All right, now we are going to have a look at bringing in the chain rule again here. So it's like I said before, if a was equal to log of e2x, and we wanted to do a cubed, that would become 3, whatever that is, squared. All right, so first of all we are going to do that. So we're going to go, I'm just running out of room, 3 log e 2x squared. All right, so I have differentiated the whole to begin with. Now with that, we are now going to, knowing the chain rule, we have to do what is inside as well. So now we're going to differentiate this, which is what I just taught. The logs go, differentiate 2x, you get 2, divided by what this function is with the log, so it is 2x. All right, from there, 3 log e 2x all squared times 1 over x. So your final answer is going to be 3 log e 2x squared divided by x. All right, last one. So f dash x this time. Let's do the same as what we were saying. So we are going to differentiate this part. Now this is a little bit different because see the cube was out the end, so it had encompassed the log, whereas this one doesn't. So we are going to differentiate what is inside. Sorry, we're going to differentiate that if it was a squared. Okay, because on the top, remember, goes the differentiation of it. So this will become 2 3x plus 2. All right, so this is way back to here. Differentiate the whole, lose the log, differentiate. Then chain rule, multiply by differentiation of what is inside the bracket, divided by original, which is 3x plus 2 all squared. Okay, from that we get 6 3x plus 2 divided by 3x plus 2 squared. So one of them is going to go, and your final answer is 6 divided by 3x plus 2. All right, you can press pause and write these down, or of course you can look at the lesson plan, but don't hang up or turn off. We're just going to do the 2 questions on the other side as well. All right, so turning the page, we are having a look at question 87. For f of x equals log e x squared plus 1, find a value when it is differentiated. So this question doesn't say please differentiate and find when x equals 2. This question says differentiate by just putting f dash when x is equals 2. All right, so from here we're going to do what we've just been taught. So we're going to differentiate this part of the equation and put it on the top, so that becomes 2x. And over the bottom we put the original, which is x squared plus 1. So that is f dash x, can't go any further with that. Now we want to go f dash of 2. So we're going to get 4 over 4 plus 1. So your answer is 4/5. Last one, so this one doesn't have values in it. We need to be able to work with what we've got. Sometimes with multiple choice questions, we feel the need to go through each one until we find the right answer. Obviously, if there's a quicker way to do it, you don't want to do that every time you see a multiple choice question. So we're not going to do that. We're going to have a look at something else. So if we were to differentiate what is inside that bracket, that becomes 2